Alright, so I've probably mistitled this work. It probably should be called key features of functions because I thought about doing it a certain way, but I think I'll change my mind. I just want to start with identifying what you can tell me about this function. What can you tell me about that first function then? So I've got a turning point here. So this is what we're looking for is key features. So things that might be more important than the average bit of information. Like I don't need to know where every point on this graph is, correct? But it's probably important that I know where my turning point is. So key features include my turning point. Where does my turning point occur? In this case it occurs at 0, 2, which is also another key feature. Y-intercept, very good. What else might we want to know if I'm looking at functions? Yeah. Let's imagine when we're sketching functions, we want to know shifts and that sort of stuff, and translations and transformations. Let's just interpret. I've got my model. I've got a model, and I want to know. I'm modelling growth, or I'm modelling population. I want to know when things equal intercepts, so y and 0, y and x equals 0. I want to know turning points. What else might I want to know?
Inverse.
Like the type of function, so what's going to happen in the future. Yeah, that leads to something. That leads to the last key feature.
Whether it's increasing or decreasing.
Yeah, increasing or decreasing. So I'll stop leading you a bit, but turning points. Now in the past, we've only been able to find one of those things. Which one of those things have we been able to find? With accuracy. Algebraically, using maths. So you've been able to find turning points in the past? For all functions? What type of functions? Are they the only functions that turn? So what we've now got is a way of finding turning points for other functions. But we've only been able to do one of these things in the past. Which one of those things? Y and x intercepts. How do we find a y and x intercept? We let y equal 0 to find our x intercept, and we let x equals 0 to find our y intercept. We've now got a technique that allows us to find our turning points. How do you think we can do that? Where's the turning point of this function?
1,
Okay, 1, -2. That's a quadratic, isn't it? Let's say it was a cubic, but just for now, just for argument's sake, and it turned there. How would I find both of those turning points? You couldn't do this a week ago, whereas you can do it now. That's the hint. Tangents. Is that a turning point there? Is that a turning point there? Is that a turning point there? Is that my tangent for that point there or not? Is that my tangent? Well, is this my tangent at that point there or not?
Yeah.
Looks like it's cutting the line, doesn't it? The tangent's got to be exactly touching the line but can't cut it. So that's my tangent there, isn't it?
Yeah.
Happy with that? What about for this function here at this turning point? Is that my tangent? With my magnetic ruler. Is that my tangent? Is that my tangent?
Yeah.
Yes. What can you tell me about all three of those tangents? What is a tangent? What is a tangent? Starts with I, R, O, C.
Literal rate of change.
3 of the 4, right? Instantaneous rate of change, correct? So the gradient of the tangent tells us our instantaneous rate of change. What's the gradient of the tangent in every one of those situations? 0. Is there a way we can find the gradient of our tangent algebraically?
Yes.
What's that process? How do we find the instantaneous rate of change algebraically? My hint at the start of this was you couldn't do this until a week ago.
Find the derivative.
Derivatives, very good. Derivative functions are our rate of change functions, correct? So all we have to do to find a turning point is what?
Find the derivative.
Derivative, and then let our derivative equal, and solve for x. So in this situation, what's my derivative? dy dx equals? Negative 4x, correct? Now where does my turning point occur? When x equals? 0. So when I let this equal 0, what should x equal? Ta-da! For this function here, where's my turning point occur? Let's get rid of my cubic. For this function here, where's my turning point occur? So when I shove this in, what should my answer be? When I derive this and let it equal 0, what should my answer be? Negative 1. Brilliant. How do I deal with this?
Shouldn't it be positive?
Positive 1, sorry, you're right. How do I deal with this? Expand it, and I should get x squared minus 2x plus 1 minus 2, which equals x squared minus 2x. Take 1. That's my y function. Derive that for me.
2x, take.
Running out of room here. 2x minus. What do I let that equal? Can I solve for x? Plus 2. X equals? What did I say I had to equal? It's magic, isn't it?
You said negative 1.
Yeah, I did. And then Mac called me up and said, "Oh, you mean 1?" I said, "Yeah, Max."
1 to 10 from x squared, take 2x, take 1 to 2x.
What do you mean, 1 to 10 from that
Yeah.
to that?
Yeah.
Power down? Take 1 off the power. Power down? Yep.
2 times 0 is 0.
I plus the 2 to both sides. And then divided by 2.
But aren't you meant to put x as 0?
No, I will let my derivative equal 0.
Oh, right.
Cool? Happy with that? Once I've got, once I know this, what do I know about my turning point? Do I know everything about my turning point? I know the x value, so how do I find my y value? I sub x equals 1 back into my original equation. 1 minus 1, take 2. Ta-da! We'll talk about max and min values later. I don't want to overcomplicate it. Happy with that? So I was going to set you a heap of textbook questions, but I think it's actually good for us to go through rather than just because you are going to practice this a lot. This is something you're going to do over and over and over again, all the way through year 12. It is important you get it done, you do it well, and you understand what you're doing. So do we understand why we let it equal 0? Why do we let a derivative function equal 0? Because the gradient of the is 0 at our turning point. So every turning point, the gradient of our function is 0. Cool? How do I find what x value is? Once I let my derivative equal 0, what do I do? How many variables will I have left in my equation here? 1. So I need to isolate my variable, get it by itself, and solve for x. Once I know my x value, what am I doing with that? Sub that back into my y value, because that will give me mine. Very good. Sweet. We'll talk about how we know it's a max or min later, but there's an education perfect task there. We may all get started on it. Let's go.